In today's video, I am going to teach you about lists in Kotlin. Hello and welcome to Learn with Tam. I'm Tarique Ali Mirza and my goal is to make you a kickass Android developer. If you are new here, I suggest that you watch this series from the beginning to get the most out of it. In the previous video, I introduced you to for, while and do-while loops in Kotlin. In today's video, I will introduce you to lists which are used to create ordered collections in Kotlin. So, without further ado, let's jump right into our system and get started. As always, let us first open Android Studio. Now click on Create New Project. Select No Activity and then click on Next. Give your project a name and then click on Finish. Once your project is ready to work with, open the App folder. Then open the Java folder. Then right-click on your package name and select New, then select Kotlin file. Now give your file a name. Make sure that you have selected file in this list. And then click on Enter. Now create the entry point function. Collections are exactly what their name suggests. They are a collection of data. In most cases, this data is logically related and of the same type. For example, a collection of odd numbers under 10. All objects that belong to a collection are called its items or elements. In Kotlin, we can choose to store a collection of data in the form of lists, sets, or maps. Let us start by understanding the difference between the three types of collections. A list is an example of an ordered collection in Kotlin, which means that the items of a list remain in the same sequence in which they were added to the list. A list can also have multiple occurrences of the same element. A good example for a list would be the list of words in a sentence. The order of such a list is important because we will need the words in the same order to recreate the sentence. Let me show you what I mean. On line number 6, I have written an example sentence. Hello and welcome to Learn with Tam. Now this sentence contains multiple words. On the next line, I have created a list using the same sentence. And the list contains the words hello and welcome to learn with and Tam. For me to be able to reconstruct this sentence using the list, the order must be maintained. So, it is better that I store such information within a list. If you are storing a collection of items where the order of the items matters, then you should store them in a list. I will show you how to store them in a list in a bit. But first, let us talk about sets and maps as well. A set is an unordered collection of unique items in Kotlin. Each item within a set must have a unique value. Let me show you an example. I am using prime numbers under 10 as an example for a set. All prime numbers under a certain value would be a good example for a data set that you should store within a set because you do not care about the order of such a set and you know for a fact that each element within this set will have a unique value. For prime numbers under 10, my set will hold the values of 2, 3, 5 and 7. A map is a collection that stores key value pairs. Each key must be unique and mapped to exactly one value within a map. They are useful for storing logically related objects. For example, we can create a map of students by storing the roll number as key and the name of the students as its value. Each roll number must be unique, however, two students can have the same name. Let me show you an example. Let's say there are three students, Tam, Sam and Zam, with roll numbers 1, 2 and 3. So, if we create a map for these three students, it will have exactly three elements, one for each student, and each of those elements will have a key. In our case, 1, 2 and 3 are the keys, and each of those keys will have a value. In our case, Tam, Sam and Zam. That was a very brief introduction to lists, sets and maps. Now, let us dive deeper into lists. At first, Let me show you a couple of ways in which you can create a list. As you can see, on line number 16, I have created a variable named sentence and I have stored the string "We are here to learn Android development" within it. On the very next line, I have created a variable named words in sentence and I am using the ListOf function to create a list using the words within this sentence. On line number 18, I have written the print statement to print the sentence as well as the variable words in sentence, which is a list of all the words. Let me now run this program so that you can see what's happening. The sentence "We are here to learn Android development" was printed as is. That is exactly what we expect. On the next line, words in sentence is printed. And in that list, we have "We are here to learn Android and development." These are all the elements that are stored within the list named words in sentence. Although it is possible to create a list manually, as we have done on line number 17, there's a better way to do the same, using the split method on the sentence string. Let me show you how it works. As you can see, on line number 20, I have created a variable named splitlist, and in that I am storing the result of the expression sentence.split, and to that split function, I am providing a blank space as a delimiter. The blank space is simply telling the method that it should split the sentence every time it encounters a blank space, which is after each word. Therefore, the result of this expression will be a list of all the words present within the variable sentence. Now, let me print this list as well so that you can compare it with the list that we created manually. Now let's run the program. As you can see in the output, both of the lists look exactly the same. And if you wish to, you can even check them for equality and see whether the answer is true or false. Let me show you how to do that. On line number 23, I am checking whether the split list is equal to the words in sentence list. Let me now run this program so that you can see the output. The last output says true, which means these two lists are identical. Moving on, we can access each element of a list by using its position. Let me show you how it's done. On line number 25, I am trying to save the first word in the list in my first word variable using the indexing operator and providing it the index 1. And later on line number 26, I am printing it. Let me first comment out all the other code that we don't need right now. And now, let's run the program. As you can see, the output is the word on position or index 1 is R. Shouldn't the first word be "we" instead of R? Let me explain. In Kotlin, as well as most other programming languages, the indexing begins at 0. Such type of indexing is called zero-based indexing. So, if we wish to access the first element of this list, we have to use the index 0 instead of using the index 1. So, let me change the value of index from 1 to 0. And let me also rephrase the print statement. And now, let's run the program. As you can see, the printed output is the first word is "we", which is correct because "we" was the first word in our list. Similarly, for the second element, you will have to use the index 1. For the third element, you will have to use the index 2 and so on. Let me show you a couple of more examples. On line number 29 and 30, I am trying to access the third word by using the index 2 and the fifth word by using the index 4 within the indexing operator. Let me now run this program so that you can see that the output is exactly what we expect. The first printed output is still the first word is "we". The second printed output is the third word is on the index 2 and it is "here". The fifth word is on index number 4 and it is "learn". That is also correct. Although I am using the indexing operator to access the elements of a list, you can also use the get method. Let me show you an example using the get method. On line number 32, I am trying to access the fourth word in the list using the index 3 and I am using the get function to get that element. Let me now run this program. The printed output is the fourth word is on index 3 and it is 2. The fourth word is indeed 2 and it is indeed on index number 3. I hope you get the point. If you are trying to access the 10th element, you use the index 10 minus 1, that is 9. If you are trying to access the 100th element, you will use the index 100 minus 1, that is 99. Let me now try to access the 10th element in this list using the index 9. On line number 34, I am trying to access the 10th element of this list using the index 9. Let me run this program. It says that there is an array index out of bound exception and the value is given as 9. Let me explain what just happened. We were trying to access the 10th element of a list which has only 7 elements. When there are only 7 elements in a list, how can it return the 10th element? Please note that the value of index that you try to access on a list must be less than or equal to the last index of that list. Otherwise, even though your IDE will not complain, the program execution will fail with an array out of bounds exception, as we saw right here. So, how do you ensure that you don't go beyond the last index of a list? For that, you will have to learn about the various properties that you can access on a list. All collections allow you to access many methods and properties in Kotlin. The most common among them is the size property, which gives you the number of elements contained within a collection. Let me show you how you can use it. On line number 36, I am accessing the size property on my list and storing its value within the variable word list size. On the next line, I am printing the value stored within that variable. Let me run this program so that you can see the output. The output is the size of the list is 7, which is actually correct. We already counted the number of elements in our list, but if you want, you can recheck it as well. Now that you have access to the size property, you can use it to avoid the out of bound exception. Let me show you how. On line number 39, I am using the size property of my list and subtracting it by 1 to get the last index. As I have already stated, if there are n elements within a list, then the last index would be n-1. I am also using that index to reference the last element of my list. Now, let's run this program. As you can see, the last word is on index 6 and the word is development. And that is exactly what we saved in our list. There were 7 words and the last word was development. Even though this method worked fine and is used in most other programming languages, it is not the ideal way to find the last index of a list in Kotlin. Let me now show you the ideal way to find the last index. On line number 41, I am using the last index property to get the last index of the list directly, instead of using the size property and then subtracting 1 from it. This last index property is not very common among other programming languages. Now let's run the program and see the output. As expected, the output from both line number 39 and line number 41 is exactly the same. At this point, it is also worth pointing out that Kotlin does not have the concept of negative index. Negative index is used in most other programming languages to specify the index of a list in the reverse order. For example, -1 stands for the last index, -2 stands for the second last index, and so on. Let me show you what happens when we use a negative index in Kotlin. On line number 44, I am trying to access the word on index -1. Let me run this program so that you can see the output. As I told you, the concept of negative index does not exist in Kotlin. Therefore, you get another array index out of bounds exception. Because a valid index is only from 0 up to the value of the last index. All other values will give you an array index out of bound exception. So please don't try using negative index in Kotlin. If for some reason you wish to find the index of a certain word within your list or a certain element within your list, then you can use the IndexOf method. Let me show you how it works. On line number 47, I am calling the IndexOf method on my list and I am checking whether the word Android is present within the list or not. And then I am storing the result of this expression within the variable IndexOf Android, which means that the index of the word Android should be saved within this variable. On the next line, I am printing the value stored within the index of Android variable. Now, let's run this program. The output is the index of the word Android is 5. Let us verify that by looking at our list. 0, 1, 2, 3, 4, 5. That looks okay. Now let me show you what happens when I provide the word tam to the IndexOf operator. On line number 50, I am using the IndexOf operator on my list and I'm asking it to look for the index of the word tam. Let us run this program. The output says that the index of the word tam is -1. But we already know that a negative index is not possible in Kotlin. It will give you an array index out of bound exception. So this is Kotlin's way of telling you that you were trying to find the index of an element that does not exist within the list. And that is why you get a negative index, which is absurd as far as Kotlin is concerned. You can look at it this way. Because you asked Kotlin an absurd question, Kotlin gave you an absurd answer in return. Now you must be thinking, what if you sincerely wanted to search whether a word is present within a list or not? Don't worry, Kotlin has you covered. You can use the contains method on a list to do just that. Let me show you how. On line number 52, I am using the contains method on my list to check whether the word tam is present within this list or not. And on line number 53, I am using the result of that expression in my if statement to decide whether I should use the word contains or the word doesn't contain within my string. Let me run this program so that you can see the print statement. As expected, the output is the list doesn't contain the word tam because we did not add the word tam to the list. Now, let's replace the word tam with Android and see what the output is. Let's run the program. As expected, the output is the list contains the word Android because the list indeed contains the word Android on index number 5 or element number 6. Up until now, we have worked with immutable list, which means that you cannot change the contents of the list, and that is why I have not shown you how you can add or remove elements from this list. In the next video, I will teach you how you can traverse or iterate over a list. But before I do that, I will also introduce you to mutable lists in Kotlin. That's all for today's video. As always, feel free to share your valuable thoughts and feedback in the comment section. If you like the video, smash that like button. If you are new to the channel, consider subscribing. And don't forget to hit the bell icon to receive timely updates of all future uploads. I'll see you in the next one.